All right, so 12-7, next to the last lesson for the year. Inequalities. Listen in one more and we're done. So example A, we'll start with this. Negative 3x plus y is greater than negative 7. And then 2x, bless you, minus y is greater than or equal to negative 4. All right, so a nice little easy linear system to start off with. So with that one, what do we want to do to those equations or those inequalities? If we're going to graph this, no. Try to get them in like slope intercept form. Get y by itself. That's what we want to try to do here because that's the easiest way to graph that. So first one, easily change that over to y is greater than 3x minus 7. And then the second one, when we do that one, you got to be careful there. So when do I have to flip that sign? Yeah, good. So y is less than or equal to 2x plus 4. So those are our inequalities that we're going to graph on the same coordinate plane because it's a system, so that means they're both together. So I'm just going to draw myself a little coordinate plane here, make sure I got room to get positive 4 on the y-axis and negative 7 on the y-axis. I think I've got room for that. And graph those. So how do I graph y is greater than 3x minus 7? What does that mean? What do you mean, open? That's right, but what does it mean? So I'm going to go to negative 7. And I'm going to go up 3 over 1. And where it says it's open. Right. What's that mean as far as drawing this? Well, what's that mean as far as how do I draw it? Well, the shading happens whether it's open or closed. Dotted or solid? This one would be a dotted line. That's what it means to be open in a linear sense. You guys have that? You know what I mean? Just what I couldn't get what I needed out of you. So dotted line on that, and then we need to do some shading. How do we decide how to shade? Yeah, that's how I do it. Some people use kind of a rule of thumb that if it's greater than, you go above. Well, if that line gets more vertical, which is above, which is below, and when the slope goes to negative, which is above and which is below, so that can make it difficult. So I just plug in a point. I'm going to test 0, 0 because that's easy to plug in. Is 0 greater than negative 7? Yeah, so that means I would shade the kind of the left side of that line, I guess would be the best way for me to describe that. So I'll shade this side. Yeah. It's been a while since we actually hand drew anything on the graph. So there's that shade. You don't have to be you don't want it too dark. You want it kind of light because you need to still be able to see your grid so you can draw your other one. I'm using a highlighter on the program here. If you want to use highlighters, color pencils, whatever, make it pretty.
They're getting today, like I think there was one section last year where there's like a different amount of colors on one side.
Mm-hmm. Yeah. You'll have some that have like 4 or 5 inequalities in one system, and you'll end up with like one little small box. That's the answer. Yeah, you're right. It's the same thing. Okay, so let's graph this one. We go to positive 4 on the y-axis, and then it's got a positive 2 slope. Dotted or solid line? Solid. Oops, I missed it. Solid because it's got an equal to mark. And then shading. Is 0 less than 4? Yes. So I would shade the side that 0, 0 is on because it's true. So the answers are there where it turns green. The overlap. Because it's a system. Overlap is the answers. My favorite part about this program is it does that. Mixes colors. Pretty good. So a linear system is just going to be that, like Hunter said, will you have more of them? Yeah, you're going to get to them that have 4 or 5 equations or inequalities there that you can graph on the same one when it's just linear stuff. That's real easy stuff to graph. Nothing just incredible about that. So let's look at one that's not linear and see if we can remember how to graph something that's not linear. And let's just mix it with a linear one so it doesn't get too complicated yet. Y is greater than or equal to x squared minus 4, and then x plus y is less than or equal to. Yes. You could. You don't really have to. You could factor that and get the x-intercepts for that and help you draw maybe a more accurate graph. I'm just thinking, how do I graph a quadratic? The way that I think about those is maybe shift, but that'd be a regular parabola opening which direction? Up or down? Does it open this way or this way?
Down.
Up. What's in front of x squared? A positive 1, so it opens up. And the vertex would be at 0, -4. And Hunter said, would you factor that? Well, you could, and you'd get the x-intercepts for that would be, the factors would be x plus 4, or x plus 2 and x minus 2, so the x-intercepts would be +2 and -2. So that can help you get the drawing. Is that a dotted or solid line? Solid because it has the equal to mark. So keep that in mind as you're doing this. And we're just getting that a little better shape than that. Okay, so we get a parabola shape, and then we want to shade that. So again, I'm going to plug in a point, and I'm going to check the origin because it's not used in the line, so I can use that. 0, 0. So is 0 greater than or equal to -4?
Yes.
Yes. So that means for this parabola, I'm going to shade the inside of that parabola. If it were false, I would shade the outside of it. That's what we're getting at there. And then I'm going to graph this linear one here. So let's graph it. Y less than or equal to -x plus 2. Getting y by itself, just subtract x. We get that. And so I'd go to +2, then I'd have a -1 slope. And that's a solid line as well. And less than or equal to, so 0 less than 2. Yes, so I'm going to shade below that line. So towards 0, 0. So the solution, or the solution area, is all of these ordered pairs in this green area. Now, is there anybody colorblind in here? I'm just curious. You are? Can you see those colors? Barely? Because some people have certain colors that you're colorblind of. I know there's different kinds. I don't know what they are, but I didn't even think about that before I started doing the colors because it's hard to see if you're. The overlap of those two shadings are the answers there. Should be the darkest area on your graph there. So there's a nonlinear system of inequalities. Not too difficult. Let's get another nonlinear system. that maybe is a little bit different. Maybe you've never graphed one like this before. I'm going to teach you how easy it is to graph that. So we have x squared plus y squared is less than 4. And then we have y is greater than or equal to x squared plus 1. So the top one is the kind of the one you've probably not graphed before. It's a circle. I mentioned that yesterday or the last couple of days when we were doing these nonlinear systems of equations. But that's really a circle. Now, you're not going to encounter one any different than that in this section on the homework or on the quiz or the test or anything or on the final. Conic sections is not really one of our nails to hang a hat on for college algebra. If you take pre-cal in the spring, yes, it is. You'll do some stuff with conic sections. You'll learn some more complicated circle equations. So this one is really easy. What you're doing, you think about a circle. In geometry, the definition of a circle is all the points that are equidistant from the center. The center of that circle is at 0, 0. All the ones in the homework I've already looked through and made sure that's the way it is. All the ones in the homework have a center at 0, 0. And then the radius, what's the radius of a circle? Halfway across, right? So it's half of the diameter out of that. Now, the radius is going to be the square root of 4, which is 2. Okay, so those are the things you need to know. So whatever number's over here, take the square root of it, that's your radius. Okay, and that makes it easy to graph. Maybe not easy to draw, but easy to graph. Who was the artist that, to show how good of an artist he was, he drew a perfect circle? That was his name. One of those old Greek artists. I can't remember I was trying to think of that this morning, and I couldn't think of it, and I didn't Google it. So, all right. So to graph that, we're going to go to 0, 0, and that's our center of the circle. And then I'm going to count my radius out in every direction. So to the right 2, to up 2, to the left 2, and down 2. And then I'm going to try to draw a circle. And here's the thing you got to know, is that a dotted circle or a solid circle? Dotted circle, which is even harder to draw. So good luck. That's a pretty good circle. I'm going to try again. It wasn't perfect. It's difficult. So I'm not looking for artistic ability. If your circle looks like a square, we got problems. But if it's semi-rounded, we're okay, because that's not perfect either. So now, with that comes shading. Okay, so can we test 0, 0? Is the line that makes up the circle going through the origin? No. So yes, we can test 0, 0. So that's getting us a point inside the circle. So if I plug that in, is 0 less than 4? Yes. So that means my shading is going to be inside of that circle. All right. And now we need to graph this parabola here, x squared plus 1. Right, that one won't factor out. So we don't really not going to help us get the x-intercepts on that, but we could get the vertex is what? Yeah, the y value would be 1. And 0 would be negative b. B is 0. 0 divided by 2 is 0. The y value is 1 out of that. So there's that. And then, we just get the parabola shape out of that. We know it's going to go kind of like that. It's going to open up. Yeah, I'm not looking to be just incredibly picky here on this particular set of stuff. And I used a solid line. Was that right? Yeah, because it's got an equal to mark. Now we need to test on shading. Can I use the origin to test?
No.
Does the parabola go through the origin? No, so that means I can. So I'm going to plug in 0 and 0. So 0 greater than or equal to 1. No, so that's on the outside of the parabola. So the shading should be where? Inside of that parabola, which would be there. And then the solution area, I'm shading away because it was false. Yeah, that's right. That's right. So my solution area is this little, I don't know if you call it a football shape, but something like that there where they overlap. Just in the top there. Maybe that's more of a, I don't know what shape you call that. Geometry is lacking on the non-polygon shapes. I don't know what you call that. Not too difficult though, right? This you're not going to get any really difficult quadratics to graph. You're not going to get any difficult circles to graph in the nonlinear part. I guess the most complicated thing you're going to have is where you've got like 4 or 5 linear ones to graph on the same plane. So you just got to be real light on your touch when you do your shading, and you might incorporate a pattern type thing that you shade this one all with lines that go this way, and the other one with all the lines that go straight up and down, and that way you get some sort of differentiation on your shading. But that is this section. It's really pretty simple. So let's look at what your practice problems for this one are. Page 921. I'll let you guys decide. We can quiz tomorrow toward the end of class, or we can quiz Monday. Because tomorrow's Friday, right? I hope tomorrow's Friday. So I'm gonna let you guys decide. It doesn't matter to me. Pays the same for me. And you don't have to decide today. If you guys decide in the morning that, hey, let's take a quiz today instead of waiting until Monday morning to do it, that's fine. Okay, so 11 through 51, omit 17, 21, 39, and 41. Okay, so those are an odd, obviously, on that. Omit those. They have the XY thing, and I don't want to do reciprocal functions in this just because there's no point in it. So I like the circles and the lines and the parabolas. That's the fun part. So we don't use it very much, Yeah, we just don't use it a lot.